Let's take a look at your axles, at your drive system inside of the vehicle. The vehicles use ball bearings. Most of them use a sleeve or a ball bearing system to stabilize the drive shaft and the axle. If you look at a system with, like, say, a U-joint design, it uses kind of like a sleeve or a cap as a bearing, and then the parts slip and slide freely inside of that sleeve, and eventually that sleeve wears out. They use a layer of grease between the parts to help keep it sliding smoothly. If you start getting dust inside of it, little bits of metal shavings from the parts occasionally binding against each other, and the parts start to increase in friction. This decreases your overall engine's efficiency because it puts an additional load on your engine, makes your engine do more work to do what it needs to do. So overall, you burn more fuel and go shorter and shorter distances. So how can we fix that? Well, there's a technology out there which I believe is called maglev bearings, or a frictionless bearing. A maglev bearing, basically put, is a high-density magnet that is placed within another high-density magnet that its field strength is sufficient that the two magnets are essentially aligned permanently with each other, and the one in the center will always float. Now, in theory, it would push itself out, and it would never always sit quite exactly the way it needs to sit, but there can be ways to force it to align itself. Now, if you do this right, you essentially create a permanently suspended shaft in the middle of a magnetic field. Now, it might take, I don't know, maybe 2 to 4 of these permanently aligned magnetic fields on your vehicle's drive shaft system in order to suspend the drive shaft, but in the end what you end up with is a frictionless bearing on your vehicle. Now, what does this mean to you? Well, right now, if you take and you try to turn your own, not your drive shaft, I'm using the wrong vocabulary, if you try to turn your axle with 2 fingers, it's probably quite difficult. And that's assuming you've taken your brakes off and you've pulled everything apart from the vehicle, and all you're doing is you're turning the little drive shaft that runs down to the differential, and you're trying to make the gears in the differential turn in relation to the drive shaft and maybe make the drive shaft on the other side turn. You could probably do that with one hand, but it's a little bit difficult. But in reality, it doesn't need to be. It should be able to turn quite easily. Well, why doesn't it turn very easily? Is friction inside of the system. There are a series of bearings that hold it in place, probably ball bearings that have been packed in thick, heavy grease, and that grease, of course, will thin out at highway speeds because it will more or less liquefy inside of the bearing pack, making it a little easier to turn. But really, what that means is you have decreased performance at low speed, but better performance at high speeds. And that's all fine for your highway travel, but you don't need to do that. Why? Because we can get rid of that altogether. So you eliminate that, and right there you should now be able to turn your axle essentially with 2 fingers, very easily make it spin. Okay? There's a huge chunk of friction we just tossed out the window. What else can we do to make your drivetrain a little bit more efficient here? Well, your brakes. Your brakes, although you can turn your drive shaft with your hand when your brakes are engaged on the car, if somebody pushes on the pedal, of course, the brakes don't allow the wheels to turn. When they're disengaged or the pedal is up, there's probably still a bit of friction on the discs if you have a disc brake system. Now, why is that a problem? Well, if there's friction on the discs and your brakes are not applied, does not that imply that that friction is making your engine do additional work to turn your wheels? Yes, of course it does. Your engine is most certainly working harder to turn your wheels because your disc brakes are still putting friction on the pads. Well, what can we do about that? Well, in the racing industry, they have high-performance disc pads. There are many different types out there that are designed to reduce the amount of heat output from friction on the pads to produce a more free-gliding pad so that the racers get a better performance out there on the field. This is absolutely critical to a race car driver to have a more effective braking system. But it still causes friction. And any friction is bad. Any friction reduces the amount of engine performance you're going to get, increases the amount of fuel needed to run your engine. So what can we do to alleviate this friction on your brake system? Well, turns out there's another problem with your brakes. It's not just simply the friction on the pads. It's something that people really don't like to talk about. It's the fact that your vehicle spews asbestos all over the roads. While many of us of my generation grew up with having to deal with, when we were in school, the schools and the federal buildings freaking out, closing sections of the buildings down to evacuate the old asbestos-laden pipes. They'd pull off the paper wrapping with asbestos in it that was used to insulate the pipes and keep them from sweating during the summer and winter months. These were energy efficiency methods that were meant to, well, save the companies and the schools money. Save the government buildings money. And it was all good ideas, but they didn't realize that asbestos causes mesothelioma, causes cancer. So despite all the lawsuits and the paranoia and the freaking out of people pulling all this stuff out of their homes and their buildings, well, here's the big secret. We still have asbestos all over the damn place. Asbestos is still used in our cars. Your car, my car, every car on the road uses brake pads that have asbestos in them. And while some industries are looking to very carefully weed that out of them, I will guarantee you your car still has it in it right now. In fact, the brake pads probably aren't the only thing in your car that uses asbestos, because it is so good at taking wear and tear and being insensitive to heat. It's a non-plastic, non-polycarbonate material. It's a naturally occurring mineral that can be used as what they call a semi-metallic in construction and fabrication, and it deals with heat very well. They mix it into bricks, they mix it into certain rubbers, and in your brake pads. When you step outside of your home and you go out there on the road, you're breathing in dust on the road. Well, that dust on the road is laden with asbestos powder. It's in the dust. It's in the air. And I'll guarantee you every single one of us have breathed it in. And I'll guarantee you there is no one out there, unless you've never left your home, that has never been exposed to it. So anybody that likes to say you haven't either has no idea or is lying through their teeth because they don't want to admit the truth. Yes, we've all breathed asbestos dust. Who's going to get mesothelioma? I have no idea. I can't tell you that. It might depend on how much you've sucked up. But what can we do about this? Well, we can take the system out of the car that produces asbestos dust altogether. Let's get rid of it. Why? Well, it causes friction on your wheels, for one. It causes a load on your engine, an invisible load that's never completely accounted for. So let's get rid of the whole damn 9 yards. Well, what do we use to replace that technology on your vehicle that's efficient enough to allow you to brake safely and dependably while getting rid of the old technology that we've been dependent on pretty much since vehicles were conceptualized, since they've become mainstream? Well, the automotive technology, the automotive community has a little-known technology out there that electric vehicles like to tinker with, which is called regenerative braking. Some of your hybrids may have it on it, and many of the newer electric cars almost certainly have it on it, which basically involves the electric or an electric motor on the wheel converting your forward momentum, your energy or your kinetic energy, into an electrical current that can be put back into a battery. Now, in electrical engineering, this was very easily demonstrated by taking a small DC electric motor and suspending it off the counter with a string and a lead weight. And if you drop the lead weight without anything connected to the two terminals that normally energize the motor would spin very freely, and the lead weight would just simply drop to the floor. But instead of putting a battery on the motor and making the motor spin, we actually decided to put a little light bulb on the motor. Now there's a load, what they call a load. We're making the motor do some work. We're making the electrical field passing through the coils do some work. You drop that lead weight again, and that little light bulb lights up. but this time the motor spins slower and the lead weight passes to the floor a little slower, because now the electrons have to pass through the motor in order to light that light bulb, in order to allow it to spin. Now, if you do the same thing on your brakes in regenerative braking, you put an electric motor on your brakes, some method of redesigning the entire brake system so that it is both protected from your new maglev bearings, your frictionless bearings, and then you incorporate an electric motor around the outside of your axle, between the wheel and the axle there, without a brake applied. The current flows freely, your motor spins freely, and there should be little to any interference whatsoever, probably nothing at all on the axle, allowing it to spin freely. You could probably turn it with your bare hand quite easily. With wheels connected and a complete load, your wheels, you should be able to spin them with your bare hands. Now, what we can do to brake the car is actually quite simple. Either A, use a regenerative braking system, which means we now, when you apply the brake pedal, it forces a closed circuit. As the circuit closes, it pushes the electrical current generated that wasn't going anywhere before and now has to go through your battery and other charging systems, or a capacitive system, which is great for giving you a little boost in acceleration in a hybrid car. When you choose to take off, it can take that energy back out of the system and put it back into your wheels, which is awesome. But we can go a little simpler than that. In the older model vehicles that are not hybrid vehicles, if you chose to convert the system, you apply this motor pack in place of your disc brakes. What you would end up now with is basically a small closed circuit under your hood with maybe a large capacitor and a huge heat sink attached to it, and that would go down to a circuit on your brake pedal, basically a large POT. They call a potentiometer. And as you apply on the brakes, it fully engages that potentiometer, allowing the circuit to more completely engage, causing more current from your wheels to pass into this big, gigantic resistor. And this resistor is essentially a humongous load, basically making the motor do a whole lot of work. The more work it needs to do, the slower the wheel rotates, and the quicker the wheel will essentially lock up or come to a nearly complete stop, because there's not enough kinetic energy in your vehicle to do it. So a big, massive load would cause your vehicle to stop. It wouldn't allow the motor to turn. That's the effect of a good brake. And when it doesn't engage, there's no friction. So I think that's good technology right there.